Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like object-oriented design, conventional VSOO design approach, design of CRC cards. Let's get started. Slide 1, Object-Oriented Design (OOD). Object-Oriented Design, or OOD, is a methodology used to design software systems using objects rather than functions and procedures. It helps in structuring complex systems by breaking them into smaller, reusable, and self-contained objects. OOD follows several key principles. 1. Encapsulation. This means bundling data and methods that operate on the data within a single unit, known as a class. This ensures that the internal workings of a class remain hidden from the outside world, preventing unintended modifications. 2. Abstraction. This helps in simplifying complex systems by exposing only relevant details and hiding unnecessary implementation details. 3. Inheritance. Inheritance allows a new class to acquire properties and behaviors of an existing class, promoting reusability and reducing redundancy. 4. Polymorphism. This allows one interface to be used for multiple functionalities. It helps in writing more flexible and maintainable code. 5. Modularity. By breaking a system into smaller modules, or objects, OOD ensures that each module is independently manageable and reusable. 6. Reusability. Once an object is created, it can be reused in different parts of the application without redefining it. 7. Maintainability. OOD makes software easier to modify, extend, and debug. For example, in a banking system, we can define a general class called account with properties like account number and balance. Subclasses like savings account and current account can inherit from account and have specific features like interest calculation for savings and overdraft facilities for current accounts. Significance. OOD helps in reducing complexity, improving system organization, and making software easier to scale and maintain. Slide 2. Advantages and disadvantages of object-oriented design. Now, let's discuss the advantages and disadvantages of object-oriented design. Advantages. 1. Reusability. Since objects and classes are modular, they can be reused across different applications, reducing duplication. 2. Scalability. OOD makes it easier to extend a system by adding new features without modifying existing code significantly. 3. Modularity. By structuring the system into independent modules, classes, maintenance and troubleshooting become easier. 4. Code maintainability. OOD follows principles like encapsulation, which reduces the risk of accidental modifications. 5. Encapsulation enhances security. Data is protected within objects, ensuring that external code cannot make unintended changes. 6. Faster development. Reusable components speed up software development. 7. Better representation of real-world systems. Objects naturally model real-world entities, making the design intuitive. 8. Supports parallel development. Different teams can work on different modules simultaneously. 9. Improves software quality. OOD reduces redundancy and ensures better organization, leading to fewer errors. Disadvantages. 1. Complexity. The object-oriented paradigm requires careful design and planning, which can be difficult for beginners. 2. Steeper learning curve. Developers must understand OOP concepts like inheritance and polymorphism. 3. Higher resource consumption. Objects consume more memory and processing power compared to procedural programming. 4. Object creation overhead. Too many objects can impact system performance. 5. Requires thorough planning. Unlike procedural programming, object-oriented design needs careful upfront planning. 6. Not suitable for small projects. For small applications, the overhead of defining multiple classes may not be justified. 7. Dependency issues. If not designed properly, objects may become too interdependent, making modifications difficult. 8. Slower in real-time systems. OOD may introduce latency in applications that require high-speed execution. 9. Increased initial development time. Since OOD involves modeling, designing, and structuring objects, initial development may take longer. Thus, while OOD provides better system organization and long-term benefits, it also introduces some overhead that must be managed effectively. Slide 3. Conventional vs. Object-Oriented Design Approach. Now, let's compare conventional, procedural, design with object-oriented design, OOD. Conventional design focuses on functions and procedures where data is manipulated directly. This method follows a step-by-step approach and is best suited for small, structured applications. OOD, on the other hand, is based on objects that interact with each other. It bundles data and behavior together, making it more scalable and reusable. Let's go through some key differences. 1. Focus. Conventional design focuses on procedures, while OOD focuses on objects. 2. Data handling. In conventional design, data is global and modified by various functions. In OOD, data is encapsulated within objects, ensuring better security. 3. Reusability. OOD promotes reusability by defining classes, whereas procedural programming lacks this feature. 4. Scalability. OOD makes it easier to expand applications, whereas procedural programs become harder to manage as complexity grows. 5. Security. Encapsulation in OOD improves security, while procedural design is more vulnerable. 6. Readability and maintainability. OOD improves code readability, making debugging and modification easier. 7. Performance. Procedural programming is often faster for small programs, whereas OOD may introduce some overhead due to object creation. 8. Modification. Changing a procedural program affects multiple functions, while in OOD, modifications are localized within objects. 9. Best use case. Conventional design is best for small, simple applications, while OOD is suitable for large and complex systems. For example, a hospital management system in a procedural approach may have functions like register patient and generate bill, whereas in a node approach, we define patient, doctor, and billing as objects with specific responsibilities. Slide 4. CRC cards, Introduction and Components. Now, let's introduce Class Responsibility Collaborator, CRC cards, a simple yet powerful tool for designing object-oriented systems. A CRC card is a paper-based representation of a class in OOD. It helps in identifying the roles of classes and their interactions before implementation. Each CRC card contains the following elements. 1. Class name, the name of the object being modeled. 2. Responsibilities, the functions or tasks this class is responsible for. 3. Collaborators, other classes that interact with this class. 4. Attributes, data stored within the class. 5. Methods, functions that define the behavior of the class. For example, in a library management system, a book class will have responsibilities like storing book details and tracking availability. It will collaborate with the library and borrower classes. Slide 6. Summary. How OOD, conventional design, and CRC cards fit together. To conclude this discussion, let's summarize how object-oriented design, conventional design, and CRC cards work together in software development. Object-oriented design (OOD). OOD focuses on designing software as a collection of interacting objects, where each object represents a real-world entity. It helps structure complex systems efficiently by organizing code into reusable and maintainable units. Conventional design. This approach follows a step-by-step, procedural methodology, making it ideal for small-scale projects with limited complexity. However, it often struggles with scalability and flexibility in larger systems. CRC cards. CRC, Class Responsibility Collaboration cards provide a lightweight yet effective method for designing object-oriented systems before coding begins. They help teams visualize class responsibilities, define relationships, and refine system architecture. How they fit together. 1. OOD offers the overall framework for building structured software. 2. CRC cards help in initial design and brainstorming, ensuring responsibilities are clearly assigned. 3. Conventional design can still be useful in specific cases, especially for simple procedural tasks. 4. Together, these approaches create a well-balanced software design methodology that is both structured and adaptable. For example, if we are designing an online banking system, OOD helps define classes like account, transaction, and user. CRC cards help assign responsibilities like transaction handling, deposits, and withdrawals. Conventional design may be used for simple operations like generating reports. By combining these approaches, we create scalable, maintainable, and well-structured software systems that meet modern development needs.